Hey everyone, I want to introduce you to an open source project that I created that can help you and your team modularize your Xcode projects using Swift packages. But before we get into it, let's go over some basics. Modularization is the technique of dividing your code base into smaller and discrete independent modules or components. The goal is to make the development process easier and more efficient by reducing the code's complexity, improving the system's maintainability, and making it easier to reuse the code in different parts of the system. Each module has a specific, well-defined function, and they interact with each other through well-defined interfaces. Now, why do we need it? The benefits of modularization are numerous, and there's a lot of content out there to help you learn more about it, but for this video, let's briefly go over some of them. Modules can be updated, tested, and debugged independently, reducing the impact of changes on the rest of the system and increasing maintainability. The clear responsibility of modules makes them easier to reuse, reducing development time and cost. Modular design makes it easier to add new features or scale the system as needed. Modules can be thoroughly tested before integration, reducing the risk of system failure and increasing reliability. Collaboration in a large organization becomes problematic when numerous software developers work on the same code base without clear borders. Modules enable clear code ownership, making them easier to develop by different teams in parallel. As your project grows, it becomes harder for Xcode to optimize your builds. When you group your code in a single target, Xcode recompiles unnecessary files during incremental builds. By modularizing your project, Xcode can create an optimized dependency graph that helps it determine what code to recompile. One technique gaining popularity in the community is breaking down your component into multiple packages. For example, you could have one lightweight package that contains the public interface and the types that your component defines. Let's call it contract. An implementation package coupled with its tests. This package depends on the contract, and as its name implies, it provides the implementations. And a package that is used in other components' unit tests, we'll call it mock. With this approach, dependencies between components would look like the following. If service A needs to depend on service B, service A implementation would depend on service B contract, and service A tests would depend on service B mock. Taking this approach with all your components would allow you to completely isolate component implementations and avoid having unwanted code coupling. There are two great videos that I highly recommend for you to check out from iOS engineers at Spotify who explain why they went with this approach and how they are benefiting from it. I'll add the links to these videos in the description. Now, what are Swift packages? They are reusable components managed by the Swift Package Manager. They are used to distribute libraries and frameworks. They can be added as dependencies to a project when hosted on Git repositories online, as well as local dependencies on the same machine. So, how can we modularize our project using local Swift packages? The challenges of the multi-package technique are the following. Creating Swift packages is a manual, delicate, and error-prone process. Setting the dependencies path manually is not a foolproof approach. Keeping the correct folder structure is also an annoying process. It is not a scalable solution for large organizations with projects that have hundreds of modules. In a large organization, you need to enforce guidelines that allow any developer to jump from one module to another and find everything where it is expected to be. And enforcing guidelines plus manual work is a recipe for disaster. Those are some of the reasons why Phoenix was created. In my company, we needed a solution to help us modularize our iOS project and ensure everyone follows the guidelines for creating and maintaining the Swift packages. So let me show you how it works. Let's say we want to modularize our project using the following approach. We want to divide our project architecture into three main layers: a presentation layer, a domain layer, and a data access layer. Each layer could have multiple packages in them, and each layer is only allowed to depend on the next adjacent layer. So the presentation layer could depend on the domain only, and the domain can depend on the data access layer. In preparation, I have created this empty Xcode project. There's nothing special about it, but I'm going to use it to add the Swift packages that Phoenix will create. As a first step, I'm going to create a modules folder under my project folder. And I'm going to open Phoenix. So Phoenix is a document-based app. It allows you to create ASH files, which are your module's configuration file. Now, as we saw earlier, each component could have a contract, an implementation with the tests, and a mock package. You can configure this with Phoenix by going to Configuration. By default, all components have only an implementation package. So let's add the contract. I'm going to call it contract. And you can specify a folder name to group all the contracts under it. So I'm going to call it contracts. You can also tell Phoenix to append the name of this package with contract. So when this is enabled, all your Swift packages that are contracts are going to have the contract name appended at the end. The contracts don't have tests, so let's keep this disabled. And I'm going to tell Phoenix to add contracts as a dependency internally inside of your component. So if you have a home feature component implementation, by default, it's going to depend on its contract. Let's do the same thing for the mock. By default, as we said, we want our implementations to depend on other components' contracts and our tests to depend on the mock. So you can specify this so that when you add dependencies inside of your project, by default, this is going to be the relationship between them. Now let's add our first component. You can do that either by clicking the new component button here or pressing Command-Shift-A on the keyboard. Each component has a given and a family name. The family name decides how you want to group your components. So I want to group all my features together, so I create a feature family. Let's also create all the other components that we saw in the graph here. Families also can be configured. So if you click on the family name in the list, you can choose not to append the family name to the component. So here we have created, for example, home with the family name use cases. By default, it's going to be called home use cases. You can choose to ignore that, and instead it's just going to be called home, settings, and user. So we want to do that, so let's keep it enabled. And by default, the folder that groups the family components together is going to be the plural of the family name. Of course, it's a very basic attempt at pluralizing words. So for the use cases, let's just fix that and call it use cases. And also, you could specify for the family a different type of dependencies than the one that you have configured in your project configuration. This will override the project configuration if you choose any values here. Also, as we said, we don't want to allow use cases to be used inside of the repositories because dependencies between layers is only allowed from one layer to the next adjacent one. So I'm going to disable the repositories here. Let's go to the features and also not allow it to be used anywhere else. And the repositories are not allowed to be used inside of the features. Now, let's start adding those dependencies. Let's go to the home feature. We know that the home feature will depend on the home use cases and the user use cases. So we can go expand the local dependencies and add home use cases. As you can see, by default, it selected for us the contract for the implementation and the mock for the tests. Same thing for the user use cases. Now that we are done adding all our components with their dependencies, let's generate those packages. To generate your Swift packages, you can either click on the Generate button or press Command-R on the keyboard. And then you have to provide access to Phoenix to your modules folder, as well as give it access to your Xcode project. Once you do that, you can click the Generate button, and then you can see that the packages are generated with success. So once that is done, you can go to your Xcode project. You will find a modules group under which all the packages that you created are going to be added. And if you go to your project folder, the modules folder that we created earlier will now have all the Swift packages that we just generated. You could choose, of course, later to modify some of those packages or components. So let's say inside of your home feature, you want to depend on a new dependency, so maybe the settings use cases. Once you save the file and generate again, you can go to your home feature Swift package, and now you can see that the Swift use cases are added. And that's basically it. Thank you for watching. I will add links in the description that should be helpful for you, so please check them out. And if you are interested, head to GitHub and start digging into the project and maybe implementing features that you need. Thank you for watching, and bye-bye.